Hello and welcome to today's webinar, Cloud Control to Major Tom, taking control of your hybrid cloud environment. This event is presented in partnership with Quest and produced by Actual Tech Media. Thank you so much for joining us for today's event. We've got a really cool event lined up for you today. Now, before we get started, just a little bit of housekeeping information that you should be aware of. My name is David Davis of Actual Tech Media, and I'll serve as your moderator on today's webinar. We want this to be an educational event, so we encourage you to use the questions box. It's there in the left-hand side of your audience console. We'll be doing a dedicated Q&A session with today's expert presenter at the end of today's webinar, so stay tuned for that and get your questions in early. We also have a number of handouts available for you in the Handouts tab of your audience console. I encourage you to check those out. And finally, we'll be awarding an Amazon $300 gift card to one lucky attendee on the live event. If you're watching this on demand, I'm sorry, the drawing has already occurred. Prize terms and conditions can be found in the Handouts tab. In just a moment, you'll be hearing from today's expert presenter. That is Mr. Mike Condy, Senior Product Management Consultant for Foglight Evolve at Quest. Mike has a really cool presentation lined up for you, but before we do that, I want to do a little bit of stage setting here. And the first thing I want to talk about is why must you control your hybrid cloud? After all, so many of us love the benefits of the public cloud, everything that it can provide us, greater efficiency, scalability, agility, pay-as-you-go pricing, where you only use what you consume, which we'll talk about more in just a moment. But first, it's no surprise that public cloud spending is on the rise. It's targeted to more than double and reach nearly $500 billion by 2023. However, at the same time, 58% of respondents to one survey say that the cost to run their infrastructure in the cloud was higher than they estimated. That's a lot. That's more than half. And what are they doing about it? Well, either they find ways to control that spending and get it down to what their business can afford, or they repatriate those workloads back on premises. And in fact, 85% of IT managers in one survey said that they were repatriating workloads from public cloud environments back to on premises. And to me, the moral of this story is you've got to control your cloud costs and control your cloud spending, or they will control you. Nobody wants to move workloads to the cloud and then later have to move them back. It's just a tremendous waste of time and money. And that's why this webinar, in my opinion, is so timely. On this webinar, you'll learn how to regain control of costs and infrastructure when it comes to hybrid cloud, how to find out the cost of your cloud spend ahead of time before you make changes, the steps to reallocate and right-size your resources, and how easily you can optimize performance without spending a lot of money to do it. I'm excited to now hand it over to our expert presenter, Mr. Mike Condy of Quest, to talk about how you can take control of your hybrid cloud environment.
Hi, so welcome to Cloud Control to Major Tom, a catchy title that gets you to pay attention to something we should be doing anyway, all of us. We're looking at how we migrate to the cloud, how we operate in the cloud, and how that relates to things that we might do in our on-premise world as well. I'm going to look a little bit to start with at some behavior and other aspects of how we work. So typically in the big wide world, when we have decided to provision workloads and things of that nature, we do the I want more bit. It's second nature to us. We've been doing it since the days of physical systems when it was really difficult to acquire more CPU, more memory, more storage, more network capacity, all of those things. So what we did is we went along and we said, actually, I'm going to have all of that up front because it's easy to ask for it up front than it is to do it after the event. And that has multiple consequences. First, it costs money. It continues to cost money, be it on-premise or in the cloud. It denies us the ability to spend that money elsewhere on other things. And it means we waste a lot. And actually, if we were on-premise, it can actually lead us to a situation, and even in the cloud, it can lead us to a situation where what we're doing is denying something else performance and resource that it requires. It's one of those behaviors that we can't stop, though. We haven't managed to in all the time we've been going through and working for decades, and it persists in the cloud environment. Which actually shows that when we're talking about things, costs and performance and right sizing and waste finding are all really interlinked. They're a continuous, ongoing process. They're a process to find waste, recycle, and reuse resources to reduce our cost, to constantly bear down on that I want more, but not too hard. We're talking about right sizing things, not making it difficult for people to get there. And so when we sit and look at the big world when we're moving to the cloud, people tend to start by maybe trying some brand new workloads there. So if you try those and you build your workloads out in the cloud, what's the first problem you'll hit? It isn't performance. It isn't even really the right sizing. It is a waste finding problem. It first shows up as a cost problem. So when you're looking at cost out there in this big wide world, that is probably the first thing you'll beat. Is your budget will be small and it will grow quietly, and then eventually you'll find that your budget is actually much smaller than your spend. And that's the first sign of trouble that most people encounter. Right? And we'll talk about that again in a little while. Once you're there, well, performance, that right sizing, oh, hey, guess what? That I want more is the first starting point for most people. So for ages and ages, you'll find that they work really well. Most workloads will sit there quite happily, and you'll sit there and only when you start realizing that you've played that problem with your cost, will you start looking in at right sizing and waste finding, and they become the key elements whilst trying to ensure performance. There's a sort of challenge in all of this, if you like. It's this term comes from project management. It's called the iron triangle. And you want the best performance at the lowest cost, but you want the least possible risk. So you want the least possible risk of something failing, but you want the maximum performance at the lowest cost. And you can only ever have two out of these three. It is not possible to make it work where you satisfy all three of them, the lowest cost, the least risk, and the best performance all at the same time. Reducing cost down to its lowest always brings in an element of risk if you want the best possible performance. If you want to take the risk away, you'll find that you lower the risk, but you no longer get the lowest cost, or you no longer get the best performance. You can have one or other of them. And that becomes interesting. It's much more interesting when you start to move things from on-premise to the cloud, as we'll see. If you right-size things, you get to defer cost. So in a normal world, that nice sort of orangey line across the screen shows us what our normal expenditure would be. It's typically rising. If you try to optimize it on a regular basis, what you'll get down there is a nice lower line that is more continuous growth, if you like, but at a lower level. And typically what we do, if you can do those things, is you end up deferring costs in that. So your performance goes nice and simply across that nice optimized line, but your cost, you've got a base growth and then this deferred element on top. So you've saved yourself some money over that time. So if we're trying to take workloads from our on-premise environment through and migrate them through to the cloud, there are two things we need to look at. The first, if you like, is performance. So imagine that we're looking through these things, we're searching through our long list of virtual machines, our workloads that we want to go and move across, and we're looking at the performance. So we're looking at how much CPU do they use, how much memory do they use, what are the maximum amounts they use, what sort of growth level do we need to give them, what storage do we use, what I/O are we doing, where are we doing it? Where are our users based? Where are our applications themselves based? Right? Where do we want them to be? And at the other side of this, the bit that people forget is to take into account costs. So there are some workloads that just simply are cheaper to run on premise than in the cloud. And there are lots and lots of workloads that run much more cheaply in the cloud than they do on premise. So we can take those, and we'd like to do the same sort of comparison we do for performance, but do it for cost. And that total picture gives us a better idea of what we should or shouldn't migrate. So how does it work? Well, firstly, we understand what things cost. Doesn't matter whether we're talking about on-premise or in the cloud here. We understand what it is that things are costing you. So from the cloud, it takes the billing data, the actual bill, not the published pricing, is what comes back here, and we work out what it costs. Can work out what you're spending it on, right? So we know where it's going, and right down to the detail of you spent X many cents per month on a network interface. So really down to that quite detailed level. We know where it's being spent. And we do the same for on-premise. We understand what on-premise, what's being spent on those. And we can dice that up, slice it up in different ways, so we can look at it through different matrices. But essentially, we understand what's being consumed and what's being paid for. So you have some sort of allocation of resource. This thing is allocated to it. We need to know what the cost of the allocation is. And if there's a resource-based or a usage-based component, we pick that out. And then you want to know, well, okay, what are we spending? So here we are in our cloud sort of environment. We have a budget we can set. 0 just means we haven't set one. We can show how much we've spent in a month, how much we've spent in the current month, and what the forecast expenditure is by the end of the year. And you can explore that so that you can build, in effect, a critical path of the things you're spending most money on. Right? So if you have to work out where things have gone, then you can do. And so here's a little cautionary tale. Long ago, a little project was running with a budget of about 1.2 million to spend over about 18 months. In the first month, about $10,000 was spent. As things just ramped up, workloads were started well below the budget, which was expected to be somewhere around about the $50,000 every month, maybe a little bit more. And the second month, around about the $50,000 was spent, and in month 3, the bill came in at about $250,000. And so then you wonder what on earth's gone wrong, because at that sort of growth rate, within a few months, the entire budget would be gone. No ability to get anywhere near to the end of an 18-month project. And so what happens with further investigation, you discover that people were coming along, starting up a workload, doing some work, going away, coming along, starting up a workload, doing some work, going away. And those who are keen-eared amongst us will have recognized already that at no point did anyone take anything down. Right? They went away, but the thing that they were using didn't go away. And so there was lots of wasted space, wasted machines, if you like. They're zombies. They're sitting there, they are running, they are consuming cost, they are to some extent consuming resource. They're there in storage, but they're also there, they're running, they're not doing anything useful anymore, but they're there. So we have to identify those and get rid of them. What's a little bit worse, if you like, is that if you add some extras in there, so you want to add a second network card to your virtual machine, your instance in the cloud, then when you remove the original instance, it doesn't remove the extras. So you can find after months and months, the big items are these unused workloads that are out there still hanging around. But over time, what adds up also are all these little extras. But month in, month out, maybe you've got $100 of extras, it's $1,200 over a year. Over 3 years, we're at $3,600. And so it keeps going and it will grow. So you need to be able to identify all those things. And essentially what we do here is we allow you to identify those things that cost you money. And from there, you can work out what you do. So you go into right sizing and waste finding. So here we are. In this particular example on screen, we can save ourselves $670 per month. And all we're talking about here is an environment of 5 virtual machines or 5 instances. Right? It's tiny. What you will see in here is the savings that can be appreciated, done in detail, so you can actually decide whether it's worth doing something. Right? So you might notice that the last one of these, at $3.80, is probably not worth worrying about too much today, but you might do it later on. But at $170 a month, the top one really just needs to be done. And sadly, it's rather more difficult to do some of these things in the cloud than it is on premise. So the better place if you're migrating things is to start on premise and optimize them before you even think about making that move to the cloud. So go away and run all of those things. There are many more things you can do because you can individually change memory and CPU when you're on premise. You bear down on those things, you decrease the allocations, you save yourself the money. And when you come to go and make the comparison between the on-premise environment and the cloud environment for cost, when you try to do that migration, it will pick the right rate plan because now it understands just exactly what sort of resources required. You'll notice in here that when we talk about utilization, we have the peak utilization, the maximum it's ever been seen to use over the period of time we've been looking at it. And you can see the allocation. So in this case, 28 gigabytes of allocation and 2.1 gigabytes of peak utilization. So if you reduce that, doesn't matter whether you reduce it to the recommended amount or reduce it to something somewhere in between, you will save lots of money. And when you move to the cloud, when it goes and does that thing, alongside making sure it has enough performance to match these peaks, plus a percentage on top, then you will get the right size. And it will be much easier to do that this way around than to do it once it arrives there, because not every virtual machine, not every instance in the cloud can be moved to a different rate plan easily. Behind the scenes for on-premise things, it's just a little plan for about how things are used. There's a sort of pricing plan that sits there. It mimics in the on-premise environment the way in which your clouds work. So here we are. Allowing you to realize the value is one of the key things. It's all very well that you see all these potential savings, but it's actually quite difficult to make that work in practice. How do you actually make sure that you get to do that? There's lots of recommendations. And if we were looking at it in, say, the VMware world or your Azure or AWS world environment, it's very difficult to do those things in just a few minutes. And I give an example. So if you have 100 recommendations, and let's suppose that you could see the recommendation, log into the right place in the native tools, find the object that you're looking for, make the change there and then, and that's a big if, because if it's working hours and the thing is actually in use, then you may not be, depending on what it is, you may not be able to do it there and then. It may be something you have to do out of office hours. But assuming you can, let's assume you can get there and you can do that and make the change in 6 minutes, and you've got 100 recommendations. It's a 10-hour day. There's no coffee breaks, no email, definitely no email, no talking to anyone else. In fact, no doing anything other than the recommendations. And so what happens typically is that nothing really happens. Maybe somebody gets to the first 2, 3, 4, 5, half a dozen, and then they give up. And you never realize the value that the tool purports to give you. And so if you want to, how do you do that? Because that 6 minutes ago doesn't seem very much. And actually, most people will know that lots of those things take longer than 6 minutes to do. So you want to be able to automate it. And only through that large scale automation where you can select things and pick a button that asks you whether you want to reclaim it now or reclaim it later. So you can schedule it to happen. That's the thing that allows you to gain and realize the value that you've been promised by whatever tool it is. So once you've done all that, and so we're doing this both sides. We can optimize and waste find in the cloud itself, and we can do so on premise. And remember, it's not just about taking things away. When you're right sizing, it's about giving the right amount. So it's possible that you might actually spend more money because it might say you need to increase the amount. But when you've done that, that's all good. Next thing you want to be able to do is migrate things from your on-premise environment. So we started with nice new applications, new build. Now we're thinking about taking stuff from an existing data center and running it in the cloud. And you'll see actually just from the simple setup that I've got that there are plenty of things in here which are cheaper to run in a cloud environment than on-premise. You'll find some that are the other way around. Right. Sometimes the difference is not a lot, but if you've got lots and lots of workloads, then eventually that adds up to being a large sum of money anyway. But you'll see, pick some workloads from whatever reason. The protection status is interesting because in our case, if they're protected, Foglight can use one of our other tools to actually make the migration happen. So we can use a thing called rapid recovery to make that migration a reality for you. Otherwise, you can use the native tools when you're ready. So we pick out where it is, we understand what it belongs to, we're able to look at these things, and we can see in our little model what this looks like. So we've picked a resource consumption for the model that it's chosen is actually low. So what that means is that we're looking at an instance type N1 custom, in this case it's from a Google Cloud, and we've assessed that that's the cheapest one we can get that matches the performance criteria we have. But in reality, we're actually using very little of the resource that's available in that particular type of instance in these cases. And you can see here, this is how close we get to it. This is the resource availability versus the consumption of these things. And so we've got very low consumption, medium consumption, very high consumption in some ones. So typically what you'll find when you do this sort of analysis is that you'll find that for one resource, we're very close to the top end of what's there in that tier, the rate plan that you're being offered, or that fits the best, and quite often low or very low in some of the other characteristics. Just occasionally you get one where it's high or very high across the board. Typically it's just one of them that's really good, and that's if you like the constraining resource. You can look across and you can see the cost of these things. So you can compare the cost on premise to the cost in the cloud. You'll notice our nice green one in the middle here is significantly less expensive in the cloud than it is on premise. It's an interesting little thing because you can do this manually, right? So typically companies will tend to hire somebody in to do this. You bring in a contractor or a consultancy firm, and they will collect all that nice data for you about performance. What they don't do is they don't understand what it costs you on premise, but they will tell you which is the best fit in terms of going out, reaching out to the clouds, finding a tier, etc. And they will try and do that. It is a very difficult thing to do. There's a lot of data to go through if you don't have a tool like this one to go and do it. And if you don't have a tool like this one, it's almost impossible to compare the costs between on-premise and in the cloud. And note, by the way, in here we've just shown a Google Cloud example. We could run this same model in our world against Amazon, an AWS environment, an Azure environment from Microsoft, a Google Cloud, some other provider, because we can actually import rate plans from others. For the big three, we pull them in automatically and do that. But for other providers, that's not the case. We have to literally, but we can pull them in and load them up from a spreadsheet and do the comparison there. So if you've got some small local provider or some specialist provider, then those things can be taken into account and done as well. Of course, once you do this, you can migrate them. There are some challenges once you're there, back into that nice cloud environment, and it's a complexity challenge, right? So the native tools don't do a great job at this point. So there are monitoring tools, there are some cost tools that are native, and they're sort of okay. They don't help you do that migration modeling, but they will give you the basics of monitoring and the basics of cost. And now it gets to be a little difficult because you start to put containers on top, or you pick out an RDS database. Maybe you're picking up an Aurora or a SQL environment or something like that. And now you've got lots of microservices and containers, and suddenly their monitoring is all disconnected. So you'll see in here that complex environment can be mapped in our world. And it can be mapped to show you things in a way that's intelligible to not just DevOps or admin like ourselves, but through to people who look after finance or HR or manufacturing. And you can do all of that for multiple environments. So I'll leave you with the set of logos of different things in there. And at that point, we'll ask for some questions.
Great presentation, Mike. Really cool stuff that you guys are doing there at Quest. We do have some questions coming in for you from the audience. First question I see here on the list they're asking is, what's the top problem that you really see people encountering when moving to the cloud?
The top problem and the first problem are almost the same. They are to do with cost. They aren't to do with performance. Right? So there's an understanding problem that is the first thing that people get to. But let's assume they've got all past the understanding, the architecture they've played with, they've experimented. The very first big problem that people hit, and it's usually the one that stays with them, is about cost. It's not to do with technology. It's not to do with making sure I have the right size of tier or rate plan. It isn't about those things. It's all about how you understand what's costing you what. And although the native tools have got better, the native tools only go and show you it at a fairly high level. The lots of things that do that. The problem is that you get what I term a zombie virtual machine or a zombie environment, a zombie instance, if you like, whatever the name you want to give to it. It's something that sits there, looks like it's doing work, but isn't really. And that happens for lots of different reasons. It's a particular problem if you've got dev and QA environments in the cloud. But it happens if you decommission something, so an application becomes replaced by a new one, and the old one still sits there for some reason. It never goes away completely. So cost is actually the biggest one, far more than the technology is.
Absolutely, yeah, you make a great point. I mean, I think a lot of people just kind of magically assume when they move to the cloud, they'll just immediately save money without really doing much analysis of the cost. So it sounds like this tool could really help with that.
It does sort of save money immediately, magically, if you pick the right workloads. If you look at what we showed a little while ago, one of those workloads is significantly more expensive to run in the cloud than on-premise, and yet another one is significantly cheaper to run in the cloud than on-premise, and they can be the inverse of one another. So picking your workloads is also a good thing, but again, it comes back to cost.
Yeah, and that brings up the question about workloads. I mean, which workloads work best and which work least, in your opinion?
That's a good question too. Small workloads, things that do discrete jobs tend to work really well. You tend to find that if you've got something small and discrete, even if it's multiple workloads, multiple virtual machines that you want to migrate across, if they're all doing a small discrete job, they tend to go quite nicely. If you have things that are doing lots of I/O, those are the things that probably go least well in terms of cost. They are the hardest to make sure you get into the right tier, the right rate plan for the performance, and they are the ones that tend to cost you the most. So large amounts of storage, large amounts of network I/O, those are the things that cost a lot of money. So I can generalize, it's not always true, but if you have high activity databases, then they're probably a bad choice. So now you come down to the question, well, do I take the whole of my application and move it across, or do I move everything other than my database? And that's actually something you have to think about. It's not even one the tool can answer for that one. It can just tell you what the numbers are in terms of the performance and the cost for you. But yeah, things that are I/O intensive tend to be poor at moving across, just from a cost point of view. The other
Okay.
thing, there's one other thing to consider if you're playing that one, is geographical locations. So be careful about where you put things. If your users are all in, the middle of the USA, then don't go putting your stuff into a data center in Singapore. It's not a great choice. You may think that sounds obvious, but it's surprising how many people look for the cheapest data center they can, forgetting that actually there's a geographical location challenge. Anyway, there you are.
Great tips. Yeah, very insightful there. Next question here is about on-prem. Why is on-prem important to the cloud?
Oh, goodness, right. It's important when you're trying to migrate. So if you migrate to somewhere like Azure or AWS, you can follow some recommendations for right-sizing after the event, changing it so that the thing is slightly bigger or slightly smaller. It can be done. You can move them from one tier to another. But there are boundaries around, or constraints, if you like, around what you can do in terms of making those moves. It is not as easy to do. And in some cases, it's so difficult, it's in effect nigh on impossible to make that happen after the event. So if you were using Foglight to do something like this, it will bring up recommendations, but it will sit there and tell you from an automated point of view, where we're looking at this at the moment, from an automated point of view, there are some things that it just sits there and says, we can't do this for you. You have to do this manually. And that manual one is to take the workload back off premise or back on premise briefly, and then migrate it the second time, because some of those changes you need to make can't be done once they're in the cloud. There's no easy way of doing it. So getting those things right before you move off-prem, do it right in your on-premise environment before you migrate those workloads. Do that right sizing and waste finding upfront, and then only move the things that have been optimized.
Okay, good tip there. That's an important gotcha. I bet a lot of companies could really fall into. So you're saving them a lot of time and money there with that. There's also a lot of questions here about the Foglight solution specifically. And let's start with the architecture. Where does this solution run? Is it on premises or is it in the cloud?
It's actually it's not if the question really is it SaaS, software as a service, or is it a more perpetual type license? Is it more perpetual on premise? You can run it in the cloud. There's nothing to stop you running it in an Azure or AWS environment. Indeed, our demo environments all run that way. But it isn't a subscription-based service in the cloud, nor is it a managed service directly from us, though we do have partners who will do that for you if that's what you want.
Okay, nice. And then could you run this just to do a migration assessment?
Yes, in an interesting twist, Just as we're talking at this point, there's a new release going out which will allow us to do license just a 60-day assessment. So it'll go away and pick up the monitoring data it needs for performance from your on-premise environment, do the comparisons, allow you to put the cost information in that we require about your on-premise environment, or use the defaults that we have. And then it will go away and do that little comparison, and you have 60 days in which to have a look at your environment and work out what you want to do. And you can export the plan at the end of it in the form of an Excel spreadsheet. So you can keep it after the 60 days as well.
Nice. Yeah, I bet that could help a lot of companies out there who are, considering moving to the cloud. And I know we're running out of time here in our presentation window. We got a lot of great questions coming in. I wanted to ask you this question before we go, and that is, what should people do to get started?
Oh, hey, come along to the Quest website, look for Foglight Evolve, and follow the links to trials. Ask a question. You'll find plenty of links there to ask questions if you can't find what you want. Just go ahead and give us a shout, and we'll get you going.
Excellent. So quest.com/foglight-evolve. It's right there on the screen. Mike, it's been really great having you on the event today. Thank you for educating us on the power of the Foglight tool and what companies need to know before they migrate to the cloud. Thanks for being on.
And thank you very much. It's been a pleasure.
Thanks, Mike, and thank you to Quest for supporting today's event. Again, check out quest.com/foglight-evolve. And thank you to our audience for joining us on today's webinar. And before we go, I want to announce the winner of our Amazon $300 gift card. That's going out to Shen Wei-Yang from Tennessee. Congratulations, Shen Yi-Wang from Tennessee. Best of luck to everyone on future events. If you weren't today's prize winner, after today's event, you'll be redirected to our events website where you can check out upcoming events. And don't forget, finally, before you go, to click on that Quest Foglight Evolve link right there. It's in the Handouts tab, and that's where you can download the free trial of Quest Foglight Evolve. Thank you, everyone, for joining us on today's webinar. Have a great day. Bye-bye.